Okay, cool. So the first question is, if x, 2y and 3z are in a AP where the distinct numbers x, y, z are in GP, then the common ratio of the GP is. So these are in AP, which means that 4y has to be equal to x plus 3z. So we can square that and get 16y squared is equals to x squared plus 9z squared plus 6xz. But we know that y squared, that's just x times z because these are in GP. So 16xz is equals to all that stuff, so I can directly write it as x squared minus of 10xz plus 9z squared has to be equal to 0, which can be factorized as x minus z into x minus 9z. But we know that these are distinct, so that's off. So you get x equals to 9z, which means that z by x has to be equal to 9, wait no, 1 by 9, but that's also the ratio squared. So the ratio has to be plus or minus 1 by 3, but minus 1 by 3 won't work because x, y and z, uh, okay fine. So because we know that x and z, if these were positive, then y should also be positive, as these are in AP. I mean x, 2y and 3z are in a AP. So if x and z are positive, y is positive. If x and z are negative, then y is negative. So the ratio cannot be negative, otherwise you will get an alternating term. So that's not nice. So the ratio has to be 1 by 3 in that case. The next question is, if bi equals to 1 minus ai and n times a is equal to the summation from I equals to 1 to n of ai, and n times b is equals to the summation from I equals to 1 to n of bi, then the summation from I equals to 1 to n of ai times bi plus the summation from I equals to 1 to n of ai minus a whole squared is. So first of all, what I would like to do is that I would like to replace every bi with an ai using this equation. So that will give me, okay, n times a is equals to the summation from I equals to 1 to n of ai. Well, that equation is still intact, but then this equation n times b is equals to the summation from 1 to n of bi, that can be written as n times b is equals to, well, what's bi? It's just 1 minus a1, sorry, ai. So if you sum that up from I equals to 1 to n, you will get n minus this summation from I equals to 1 to n of ai. So if I add these two equations, that will give me n times a plus n times b is equals to n, and here we assume that n is a natural number, so that pretty much gives me a plus b equals to 1. Okay, nice. And what else do we have? First of all, just put that on the top. So a plus b equals to 1, that we know. Okay, fine. And what are we supposed to find? We are supposed to find the summation from I equals to 1 to n of ai times bi plus the summation from I equals to 1 to n of ai minus a whole square. Well, the same trick once again, I can write bi as 1 minus ai. So this will be the summation of ai minus the summation of ai squared. Okay, and then this can be written by expanding it. So the summation of ai squared minus 2a times the summation of ai plus you got a squared and you got n. Okay, fine. So summation from I equals to 1 to n of a squared, that has to be n times a squared. Okay, that's nice. So first of all, you see that these two cancel, then you can recombine this to write it as 1 minus 2a into summation of ai from I equals to 1 to n and plus n a squared. But now we can use the fact that summation of ai from 1 to n, that is just n times a. So this can be written as n times a minus 2n times a squared plus n times a squared, which is nothing but n times a plus, wait no, minus n times of a squared, which is n times a into 1 minus a. But wait a second, we know what 1 minus a is, it's just b. So n times a times b, where is that option? Yes, it is the fourth option. Yes, just hope I didn't make any kind of mistake over there. Yeah, you got a plus b equals to 1, so that has to be like that. Fine. So let's move on to the next question. If, wait a second, first delete this. Yeah, so you got, if 1 upon 1 square plus 1 upon 2 squared all the way till infinity is equals to pi squared by 6, then 1 upon 1 squared plus 1 upon 3 squared plus 1 upon 5 squared all the way till infinite terms. What is that supposed to be? Okay, fine. So we can write this. Okay, fine. So let's do it. So you got 1 upon 1 squared plus 1 upon 3 squared plus 1 upon 5 squared. It keeps going like that. Plus 1 upon 2 squared plus 1 upon 4 squared plus 1 upon 6 squared, and it keeps going like that. You can see that these are the missing terms. So that has to be equal to 1 upon, just call this thing S for now. So S plus, what is this thing? This is just 1 upon 4 into 1 upon 1 squared plus 1 upon 2 squared plus 1 upon 3 squared. It keeps going like that. So that's just S plus 1/4 of whatever this sum is, but we know what that sum is. We assume it's pi squared by 6. So it's pi squared by 6. I mean, like right, 1/4 of pi squared by 6, I think. Yeah, looks correct. So 1/4 of pi squared by 6. But we know what this sum, this complete sum has to be. It has to be equal to pi squared by 6 itself. So that gives me that S is equals to 3/4 of pi squared by 6, which is pi squared by 8. So that's an easy question. Cool. Let's move on to the next one. So the next question is, consider the sequence. Let's do the sequence 1 2 2 4 4 4 4. Okay, so 1 times 1, then 2 of these 2's, then 4 of 4's, and 8 8's, and so on. Then the 1/05th term will be, okay, fine. Okay, so 1/05th term will be, so you can see that the last 2 was the third term, the last 4 was the 3 plus 4 7th term, then the last 8 was the 7 plus 8, which is 15th term, and it will keep going like that. So what can we say about the last of a specific number? Okay, fine. So suppose we talking about 2 to the n minus 1 power, maybe, I don't know, maybe k minus 1 will work better. So we want to find that what number of term was 2 to the k minus 1, I mean the last 2 to the k minus 1 in the series. So how do we do that? First of all, you got 1 1's, then 2 2's, then 4 4's, then 8 of these 8's, and it will keep going like that. So this is for 2, this is for 4, this is for 8, till you eventually get 2 to the k minus 1. So 2 to the k minus 1, 2 to the k minus 1's, right. So that's going to be the number of, okay, fine. You got the idea that suppose you got the sequence 1 2 2 4 4, it keeps going like that till you eventually get 2 power k minus 1, 2 power k minus 1, and this is the last 2 power k minus 1, then this is this number of term, okay, fine, which is going to be 2 power k, right. So 2 power k minus 1 upon 2 minus 1, that's just 1. Nice, looks correct. Fine. So we can see that a sub 2 power k minus 1 is 2 power k minus 1. Okay, that's nice. So what we want to find is then the 1/05th term will be. So hopefully we will be able to find some power of 2 which is near 1/05th, and we know that the nearest power is in fact 1024, which is 2 power 10, which can be written as 2 power 11 minus 1. Therefore a sub 2 power 11 minus 1 is equals to 2 power 11 minus 1, which is just 2 power 10 basically. So that's just 1024. Let's write it as 2 power 10 maybe. So you got 2 power 10, right. So the last 2 power 10, that has to be the 2 power 11 minus 1th term. So the next term, which is, wait a second, so 2 power 11 minus 1th term, fine. So yeah, that looks correct to me. Wait a second, 1024 is 2 power 10, which is 2 power 11 minus 1. Yeah, so 2 power 10 is a sub 2 power 11 minus 1. We want to find the 1/05th term, which means that it is in fact a, what is this thing, to power 11 minus 1, that is, are we really wanting to find that thing? No, I don't think so. So no, we are going on the wrong direction most likely. Right, we want to express this as 2 power k minus 1, the 1025th term. Right, so we want this number to get very near to 1025th. So you want 2 power k minus 1 to be approximately 10. Yeah, so k has to be 10 in that case. Fine. So in that case you will get that 1023. Right, so a1023, which is nothing but a 2 power 10 minus 1, that is 2 power 9. Okay, and in fact it is also the last 2 power 9 in the sequence. So the very next term, which is a1024, that will be 2 power 10, and similarly a1025, that will be 2 power 11, 2 power 10. Okay, so yeah, that looks correct. So the last, I mean the 1025th term will be 2 power 10 in this sequence. uh, yeah, so because this is not a very well defined sequence, right, it's not defined in terms of n, it is hard to come up with the answer. Okay, so I will see you in the next video, I think. So thanks for watching the video.